Lesson 11.6, radical expressions. So we're going to be simplifying radical expressions today and tomorrow. So a radical expression is any expression that has a square root or a radical sign. Looks like a square root sign. Sometimes it could be a cube root if there's a 3 there, or a 4th root, 5th root, and so on. Here are some examples of radical expressions. You can see that all of those have a radical sign in them. The expression under the radical sign is called the radicand. It may contain numbers, variables, or both. It may contain one or more terms also. So you got sometimes numbers, sometimes letters, sometimes both. Could have more than one term. Okay. What we're going to be doing, spending our time looking at, is trying to find the simplest form of radical expressions. So an expression containing square roots is in simplest form when the radicand has no perfect square factors other than 1. In other words, there's none of these, the factors that we have, or the squares that we have, none of those are in there. Okay? They're not factors. The radicand has no fractions. Okay? So you can't have the square root of d over 4, for instance. Okay? Similar to this one, but that's not in simplest form. And there are no square roots in the denominator. Right? So you have to simplify all of those situations. Remember that positive numbers have 2 square roots, one positive and one negative. However, if you just see the radicand, or the radical here, it indicates a non-negative square root. If it was to be negative, then there would be a negative sign in front. The only time that you're going to put it could be a positive or a negative, is when you're actually solving an equation. Okay, and we've done those before. So you have to be solving an equation there. If we have x squared, you should write the simplification of that as the absolute value of x. Because we don't know whether x is positive or negative, because it could be both. It could be either or. So here we have some examples. Now, whenever you're simplifying radicals, if you have a fraction, the first thing you want to do is, can I simplify my fraction? Okay? If I can simplify the fraction, I want to do that first. So here we have the square root of 2 over 50. Can that be simplified? Close, Mr. Thompson. Okay. Mr. Etchu, can I simplify that? Okay, 1 over 25, good. I can divide both parts by 1, and so, or by 2, so we have the square root of 1 over 25. Okay. Now, we look at 1 and 25. Are they squares? Are they perfect squares? Yes, because 1 squared is 1, and 5 squared is 25. So this simplifies to 1 over 5. You simply have 1/5 then. Okay. What? That surprises you? Yeah. Okay. Letter B. Now, if we have things squared under the radical, right, if possible, you want to get rid of them so they're not squared anymore. So here we have 8 squared plus 15 squared under the radical. So what does 8 squared plus 15 squared equal? This is the square root of 64 plus 225, which is the square root of 225. 89. Is that a perfect square? Okay. And if it is, how did you find it that it is? Dylan, is that a perfect square? Okay, and how'd you find it? Okay, just take the square root of it. Good. Okay, and you get 17. So really, we wrote down over here all the squares to 12 squared. Maybe you want to do it to 20. Okay. Wouldn't be a bad idea. All right, letter C. Now, letter C, we have a trinomial. And there's obviously the only thing squared there is the x, from what we can see. But because it's a trinomial, what might I be able to do? I might be able to factor it. Okay? Can I factor this? What are the factors of 9 that add up to negative 6? 3 and 3, right? Okay. So this is actually the square root of x minus 3 squared. So it says up here that, oops, if I have this situation here, we're doing the square root of something squared, then what I get is going to be the absolute value. So in this case, then, the square root of x minus 3 of that quantity squared is going to be the absolute value of x minus 3. Not just x minus 3, but the absolute value of it. Because it could be a positive or it could be a negative number. Either way. Okay. Okay, so I want you to do A and C here. All right. Now, there are two different rules that we're going to look at with regards to simplifying square roots. One of them is the product rule or product property, and the other one is the quotient property. So first of all, we're going to look at the product property. And the product property basically says that, oops, I don't want that. If we have the square root of a product, okay, of two numbers multiplied together, I can write that as the square root of each of those separately being multiplied. Okay? So the square root of A times B is equal to the square root of A times the square root of B. And in both cases, that letter has got to be a positive number. That's what A greater than 0 and B greater than 0 is equal to. Okay? All right? You got to have positive numbers. Okay? So they show the example here, the square root of 4 times 25. All right? I could write that as the square root of 100, which is 10. Or I could break it apart and say it's the square root of 4 times the square root of 25, which is 2 times 5, which is 10 also. So either way, I would get the same answer. Now, the reason that we're going to be working with the squares, and we wrote down a list of all of the squares, at least up till 12, is because we're going to need them to simplify radicals. So here we have this example here. We're going to simplify the square root of 24. So when you think about the square root of 24, first of all, is it a perfect square? No. Okay. So what I want to do is I want to find the largest perfect square that goes into 24. So I go through look at my list of perfect squares. 1, 4, 9, 16, 25, and so on. What's the largest perfect square that goes into 24? Does 16 go into 24? No, it doesn't. Okay? So just look at our squares. We know 1 does, right? Okay. Does 4 go into 24? Yes. Does 9? No. Does 16? No. Okay. So the only one that goes into 24 would be 4. Okay. So I can rewrite this as the square root then of 4 times 6. Okay. The perfect square 4, and then the number that's not a perfect square would be 6. Okay. Because 24 is 4 times 6, right? Okay. Now, using the product property says then that I can write this as 2 separate radicals. So I can pull it apart. I pull it apart, and now I have the square root of 4 times the square root of 6. Okay. All right, so first I broke 24 up into factors, where one of the factors was a complete square. After I do that then, I can pull them apart and write them as 2 separate radicals being multiplied together. Okay. Now, is there a square root of 4? What is it? 2. Okay, is there a square root of 6? No. So then my final answer then is going to be 2 times the square root of 6. And remember, just like if there was a variable here, it means times. So this is 2 times the square root of 6. You don't have to put a times sign there, but understand that that's what it means. Okay. So we're looking for the largest perfect square that goes into the number. Write it as factors of that perfect square and whatever it's multiplied by to get the number. Okay. Use the product property to pull them apart, and then simplify the one that is a perfect square. Let's look at another one. Okay. Oh, this one's got letters in it. Okay, variables. Now, whenever there's more than one thing, okay, under your radical, or for the radicand, the first thing you want to do is you want to pull them apart using the product property. Okay? So since this has both x and y, the first thing that I want to do is pull the x's and the y's apart. I want to separate it. Now, is x cubed a perfect square? It's not, is it? Okay. Can I write it as the product of a perfect square and something else? Okay. Cheyenne, what could I do? You don't know? Anybody know what I could do? Lexi? It's x times x squared, right? Okay. I could write x cubed as x times x squared. So we were able to take x cubed and pull it apart so that it says x squared times the square root of x. Now when I simplify that then, I don't have an answer. So what about simplifying that? Is y to the fourth a perfect square? Yes, I have here a lot of yeses, okay. If it's a perfect square, then Colin, what is the perfect square then? Y to the second power, very good. So here I'm going to have, this part is going to give me y to the second. If I take the square root of x squared, I get x, right? Okay. And then we have the square root of x left over. So I'm going to rewrite it So this is x y squared times the square root of x. Now make sure, okay, and some of you might want to do this, you might want to put parentheses there just so you don't misinterpret the 2 as being here for the radical, okay? Because sometimes we'll be using radicals that are like a cube root or a fourth root, and you have to make sure they don't go there. So if it's a variables, we're looking for perfect squares also. So if it's variables for perfect squares, we're looking for similar to like x squared, or x to the 4th, or x to the 6th, or x to the 8th. In other words, x raised to an even power. And if raised to an even power, the square root of it is what? The square root of it is half of that. So the square root of x squared is x. Square root of x to the 4th is x squared. Square root of x to the 6th is x cubed. Square root of x to the 8th is x to the 4th. So any variable with an even-powered exponent is a perfect square, and the square root of that then is just the exponent that's half that amount. So do A and B. The quotient property says that if we're taking the square root of a fraction, then I can take the square root of both the numerator and the denominator. So here I have the square root of a fraction, and I can pull it apart, so it's now the square root of the numerator divided by the square root of the denominator. Now they have a rule here that goes along with it. It says where a is greater than or equal to 0 and b is greater than 0. Does anybody know why it's not greater than or equal to for b? It's just greater than? Okay, Ruth? Very good. Okay, all right, I heard it from a couple other people too. Very good. Yep, we can't divide by 0, so for the denominator, it has to be greater than 0, not just greater than or equal to. So the fact is that square root of b cannot be negative, but it can't be 0 either, because then I would be dividing by 0, and that's impossible. Okay. All right, so take a look at a couple of examples here. So we have letter A, the square root of 5/4. Now, it's very important when you write these that you use fraction bars correctly, okay? And in other words, that they always have to be horizontal. And make sure that if you ever have radicals in the numerator or the denominator or just the numerator, make sure that your fraction bar goes completely underneath that. So I can take the square root of 5/4, and I can write that as the square root of 5 over the square root of 4. Using the quotient property, I can pull them apart. Is there a square root of 5? No, there's not. Okay, so my answer is going to have square root of 5 in the numerator. Is there a square root of 4? 2. So I'm using the horizontal fraction bar. Make sure that my fraction bar goes all the way across. Okay, and then put the 2 in the denominator. Because if the fraction bar doesn't go all the way across, then sometimes it looks like this whole thing's still under the radical, doesn't it? Okay, so be very careful of that. Make sure that if you have a fraction, that you completely separate the numerator from the denominator. We don't want this. That's a no-no. Okay. Now I'm going to cover up this other one. I don't like how that's written. All right, so that's gone. Goodbye. Okay, now, letter B. Square root of m cubed over 9m. Now the other thing is, when there are fractions, okay, with variables, okay? Number one, simplify the fraction first, if you can. Okay. Simplify the fractions first, if possible. Okay. Whether it has variables or not, sometimes. Okay. All right. But, so we look at this square root of m cubed over 9m. Can I simplify that first before I do anything else? Okay. There's an m cubed in the numerator and the m in the denominator. Can I do some canceling there? Yes, I can. I can cancel 1m, can't I? Okay. So this is equal to the square root of m squared over 9, because one of the m's cancels. So then I can write it as two separate fractions using the quotient property. And then if I have perfect squares, which I do here, I can simplify it to m over 3. And like I said, make sure your fraction bars are horizontal. Do not do diagonal fraction bars. Okay? Easy enough? Somewhat. If you just give me numbers, it's fine. If you give me variables, then it's a little tricky, right? Okay. All right. So I want you to do A and C here.